Hello everyone. Today we're going to be solving a problem of getting data from multiple sources and returning back the combined results. We're going to be using Go's concurrency model to accomplish this. So let's get started. Alright, here we have 10 API calls that need to be processed. At the moment, there's only one worker to handle them all. It could take a while to process all 10 and send the results back. This can be inefficient and prone to delays in responding back to the user. To help out, let's give the single worker an extra hand. Here we have two workers. Each one will grab an API task, gather the data, and store it for processing. After finishing a task, the worker will grab the next one available. We could have added more workers here, however, we do not want unlimited workers. This is because resources are generally limited per environment. In our case, we have 10 API calls and 2 workers. And then from here you can see that the first one, as a demonstration, processed 1 call. The second one processed 3 calls in the same time frame. So what's going on here? Well, the first one, it had to wait for the API to come back, and it took a lot longer than the second one, who was able to process 3 of them. And before we get to the code, let's show you a little bit what happens at the end. And that is, what does it do with it? So at the end, we want to send out the aggregated data that we received. Alright, so I already have the code environment, so let's jump into the code. And the first thing we want to do in our code, we want to say, we want to set up how many API calls we're going to do. So API calls to do is 10. And how many workers we want? Well, we said earlier we're going to have 2. That's because we're simulating limited resources. And then we want to set up the wait group. So we define our wait group and Go. We do a sync.wait group. That's how you make a wait group. Define the wait group. And now we need a place to say, hey, I need to set up the limits now. I want to limit these workers. So in Go, you use a semaphore. So let's make our semaphore. And now we're saying it's set to 2 so that we can only have 2 workers at a time. And then we need a place for all of our results to go into. Now I'm going to make this a little different. I'm going to make it store an integer. We're basically going to make it count to 10. And then print out the results. Alright. So now let's go through each call that we're going to simulate. And the first thing we want to do, I want to expose this I down below. And that's just to show you which one it's working on. Okay. Next up, we want to say add our wait group, and we add 1 to the wait group. So we're adding 1 for each task that we're going to do, and basically we're going to have 10, so it's going to add up to 10 eventually. Now you probably say, well, if we have an add, how do we decrement or get rid of one? Well, that's done in the Go routine here. So we say go func to start our Go routine, and this is where that happens. We say defer wait group done. This says at the end it's going to decrement by 1 when it gets done. So when it gets down to 0, then it's finished, and it'll go past the wait that we're going to have down here, which you don't have set up yet. Okay, so in this Go routine, we want to what we call acquire a slot, because we have 2 of these, right? So we want to take one to go do the work. We're trying to set up the limit. So I say, okay, I'm going to take one. I'm going to set up the limit. I'm going to redo that a little bit differently. Then I'm going to say, okay, let's tell where we're at right now. So we're going to say, we're working on call, whatever call it is, and then we're going to say worker, which we're going to make a little method called worker. We haven't made it yet, but we're going to. And what it's going to do, it's going to pass the one that's working on, and then the results. Okay. Then afterwards, we're going to say, well, we're finished now, so let's print to the screen that we're done doing that specific task. So now we're saying we're done. Great. And then next up, we want to release the semaphore, which is basically, here we're saying acquire a slot. Then down here, we're going to say release the slot. So when we're done doing this task, we got to release it. So we said we have 2. So as soon as it gets done, it does this one, then it'll require another slot, and so forth until it gets done. Okay, so let's finish off the go routine. And now let's define our little method down here, worker method. So we're going to do that. Now, normally we're going to do the work, but instead of I, let's pass a 1, because I was told that we're going to count till we get to 10. Now, you could do this, but then you're going to get like a 45 or something like that, because based on the numbers and how the looping and so forth that we're doing. But for right now, we're going to say do the work, and we're going to put the result of 1 into there, so it just counts 1 at a time. So each one of these should have 1. Okay, now that's happening. Now we're going to say, all right, we need to wait for stuff to get done. And that's what the wait does here. It says, I'm going to wait until this counter goes down to zero. So it's going to wait till done, goes back, done, all these get done, eventually goes down to 0. Okay, so now to get our results, we're going to say close the channel down, and then we're going to print out our results. In our case, we're going to send the results, because we talked about at the end of our diagram from earlier, we said, well, we got to process them, and then we got to wait for them, and then we're going to send out the results. So now we're going to say send the results. So send results. And so we're going to send the results, and we're going to send it here in a minute. We need to pass it something though. So let's first get the results out. So let's say sum is equal to 0, and then we're going to set the for loop to get everything out. I could do it like it's suggesting, but I'm going to do it a little differently here. And I'm going to basically, so you can see the following, we're going to do this. Now, what that means is we're looping through here. We're going to get each result out. I could do the for range thing, but I just want you to see this arrow here. So basically we're saying get the results out of this channel and put it into here. And we're going to keep adding up as we go. And then when you get done, then we're going to send the results out. So we're saying send the sum. Send the results the sum. So now we got to do that. So we define our method. And then let's just print it to the screen, because we don't really results sent, and then the sum itself. Okay, so let's see if this works. Let's go switch it over to our terminal, and let's run our program. And now you see that it went, added them all up, and became 10. And you notice that none of these aren't quite going in the order of. They're not going into a serial, like right in a row. That's just because how the go routines are working. So if you're expecting them all to go right in a row, that is not the case. So anyway, so what would happen if we put like a delay in there? So let's do that. And what we're going to try to do is show you that one's going to be at 1 second, the other one will be at 2 seconds. So let's go back into our code here. So let's hop back into there. Alright, now in here, oh well, don't worry about complaining that we haven't used this. I just decided we're not going to do that at this point. But in here, let's set up on our simulation of work, let's make things take a little bit longer. So let's say for, well, very close to what it's saying here, we're going to say if it's divisible by 2, then let's say a timer. So we're going to sleep, sleep 2 seconds is good. So we'll sleep 2 seconds. Otherwise, let's sleep for 1 second. Okay. So now when these run, you're going to see a little bit of a delay. So where one will run in 2 seconds, the other one will run in 1 second, depending if it's divisible by 2. Alright, so let's switch over, and I'm going to clear this out and run it again. Now if you noticed, obviously the order's much different now, because basically if it's divisible by 2 or not is when it got done. But if you look at it, you'll see when it was making the call, and then when these were completing. And as you can see, as they were getting done, then it, obviously kept grabbing more until it was done, but only ever did 2 at a time. And then the final result is obviously should be 10. Okay. So let's switch back to our code one last time here. Alright, so back in the code editor, now as we said here, we print out that we made a call and the call ended, so we're done. And it basically went through all 10, only 2 at a time. So you can see this can be useful for projects where you're trying to you have limited resources and you know you're trying to get something out, but you don't want to not spawn, but start a whole bunch of goroutines. You can say I can only want 2, I want 4, I want 5, whatever is suitable for the environment and what you're doing. Anyway, so that's all I had to show you today.